statistical topic. Now, let me tell you this. Statistics is more or less like a story that goes on and on and on and on and on and on, depends on how far you want to go. Okay, understanding of the quick review that we've done is a prerequisite, or I'm going to say, will enable you to understand whatever we want to be doing from now. Okay, I want to welcome you to this topic, Introduction to Bootstrapping. Okay, so in the outline, I'm basically going to walk you through the concept of bootstrapping. Of course, what situation do we need this bootstrapping? Then, of course, I'm actually going to walk you through the practical application of that now. Now, let's get started. You know, let me tell you this. We just finished quick review now. And I want to say, the takeaway from the quick review that we did, we were trying to conduct statistical inference. We are conducting statistical. Why do we need to conduct statistical inference? What is statistical inference in the first place? I'm going to let you know this. We find ourselves in a world. We are looking for knowledge. We're looking for information. So which means we actually need parameter. And what do we mean by parameter? The parameter is population characteristic value that we seek to determine. Okay, parameter. Okay, this parameter here, okay, is a population characteristic value or characteristic values that we seek to determine. This is exactly what we have in mind. Where will I get this parameter from? I'm actually going to get that from the population, and that's why we call it a population characteristic value. This parameter that I'm talking about could be mean, proportion, ratio, and so on like that. In our quick review, we focus on the mean and proportion. That was what we focus on. But let me tell you this, the fact remains, it will be impossible to study everybody in the population, because the only way you can get this exactly, is when you study everybody in the population. That's not possible. We don't do that. We normally conduct survey most of the time. When you are conducting survey, you know what we always do? We take a sample, right? Believing when we take a sample and we follow the rules, we play by the rules, then the statistical inference will come in. What do I mean by statistical inference now? Statistical inference is a process of analyzing sample, and you generalize the result from the sample on the entire population. I'm going to say that again. In statistical inference, what we do, we take a sample, we analyze that, and whatever result that we have, we generalize that on the entire population. That's what we mean by inference. Statistical inference is like a judgment, making judgments. That's what we mean. Now, do you know, and I've said, statistical inference, when we want to conduct statistical inference, we want to make judgments, we can make judgment in two ways. Either by constructing confidence interval or by testing hypothesis. But let me tell you this, the quick review that we just finished, we were able to conduct statistical inference We were able to construct confidence interval. We were able to test hypothesis on an assumption that what? That normal distribution applies. I'm going to say that again. We were able to conduct statistical inference on assumption that the probability distribution of the statistic, the probability distribution, when I say statistic, what I mean now, X bar, P car, that is what I mean by statistic. Don't forget, we're using this guy in place of this guy. We're using this guy in place of that guy. So what I'm now trying to talk about is that we were able to validate whatever we're doing in what we just finished on the assumption that the normal distribution exists for the statistic. But what if in a situation where normal distribution fail, assumption fail, we can no longer use that method that we use in the quick review. Then what are we going to do? Bootstrapping that we want to do now is a way out. You now see the reason why statistics is a story? There's a connection between the topic that we've done before and what we want to do now. Therefore, I'm seeing this bootstrapping now as an intervention. You know. Oh, I'm going to write that. So I'm saying bootstrapping now. The bootstrapping is coming in because there's a problem. Okay. So it's coming in as an intervention to address the problem of normality. Let me tell you this. Even though the population we're choosing from is not normal, we can still use the conventional approach provided central limit theorem applies. And the central limit theorem said when the sample size is large, and how large is a large? 30. When n is greater or equal to 30, we should be fine. But what if in a situation where the sample size is small, then we cannot trust our standard error anymore. We cannot trust the confidence interval that we construct using the conventional method. We cannot trust the hypothesis testing that we conduct during the conventional method. And that is the reason why we need bootstrapping. Okay, now we're talking about bootstrapping. We got 3 versions of that. We have the non-parametric, the semi-parametric, and the parametric. But the one I want to focus on now is the non-parametric one that will involve resampling. You know what? We've taken a sample from a population. We're not going back to the population. We're basically focusing on that same sample. But you know what? We're actually going to, the resampling is a way of producing several versions of that same sample. But like I said, there's no new information. Do you know the only way we're going to have new information? When we go back to the population. Why is it that we don't want to go back to the population? Because we're limited by budget. We are limited by budget. We don't want to play around the sample that we have. We want to produce several versions of the sample. Okay? Now, I wanted to take a look at what I'm having now. You can see we got a sample right on top. The one we've been doing before, the sample will come from the true population, right? We're choosing sample from the true population. That's the one we're doing before, right? And from the true population, when I take sample, let me just tell you the idea behind what we've done before. The idea behind what we've done before, we are assuming that we have visited the population several times. But do you know what? The truth remains. We only visited one time. But the assumption is we are visiting, because you know why? We have to pretend as if we are visiting the population several times. It's because of the fact that when we are working on the same thing, we go into the population to find the mean, we're going to get different values for the mean. Our estimate will not be the same. But let me tell you this, provided that the distribution of the estimate, that of all the estimates together follow normal distribution, that validates the approach we were using before. We did not go into the population several times, we only go once. But do you know what we want to do in bootstrapping? We want to have a way to estimate sampling distribution. Even though we did not go into population several times here, we now want to pretend with the sample that we have and provide several versions of that sample. So in a way, we'll be able to estimate sampling distribution. That's exactly what we want to do. Take a look at this now. When I go into this, the sample, I'm going to have several versions of that. On each several version, I'm going to compute the estimate. Then I will look at the distribution. If the distribution is normal, then I'm fine. I'm basically fine. Now, this is the situation. The one we were using before, follow this up, this is what we assume. We have a population. Let's say, for instance, I really want to know what is the average household income in the United States? And all of us in this class, we're working on that same subject. We go into the American population. You go, I go, everybody go. We decided to take the same sample. We're choosing at random. That is why we're going to have sample 1, sample 2, up to sample 1,000. If we are 1,000 in number, right? And each of us, we come out with what? With mean value, right? How many means are we going to have? 1,000 if we are 1,000 investigator. Now, because the values of this guy varies, okay, we're going to look at the distribution. If it is normal, look at that. If it is normal, then what happens? If it is normal, right, that validates the approach that we were using before this bootstrapping. This is what they assume. Even though they did not go into population several times. But do you know why they actually believe they've gone into population several times? Because they rely on central limit theorem. They provided the sample size they choose is 30 or more. This is achieved. Take a look at this. In reality, however, we're stuck with one sample. Don't forget. We therefore cannot ever know the actual sampling distribution. There's no way to know the actual sampling distribution. Because if you really want to know the actual sampling distribution, you know what you need to do? You need to take possible samples from the population. Do you have time for that? When you take a possible samples from the population, you know what happened? You have defeated taking sample in the first place. Because in the first place, you want to run away from studying everybody in the population. Don't forget you are limited by budget. Now, for the same reason, we cannot peer into all those other lives we might have lived, but didn't. There are some lives which we know that we're supposed to live, but we didn't. Because the only way to look at the overall of salary is when we have lived every life. That's not possible. And that was why Robert Frost, said this, he called it the road not taken in 1916. 2 roads diverged in the yellow wood. And sorry, I could not travel both. And the one traveler long I stood and looked down one as far as I could to where it bends in the other growth. Look at that. Now, Let me now tell you this. What we normally do in bootstrapping, from a population, we take a sample. From the sample, we take several samples from that. What is our belief? Our belief is this. Our belief is this: uncertainty arises from randomness. Randomness. From randomness inherent to our data generating process. As uncertainty arises from randomness inherent to our data generating process, if we can simulate randomness, then we can approximately quantify, uncertainty, which is what we want to do in our bootstrapping. How can we quantify uncertainty? And this is the process. Take a look at that. I've already taken the original sample from population. I do not want to go back to the population anymore. I don't need new information. But I produce several versions of that original sample, even though there's no new information. I'll use sampling with replacement. And on each of the sample, I got my estimator. And of course, I look at the probability distribution of that. If it is normal, then I've done a great job. Of course, you can use the histogram to do that. I'm going to show you an example now. Let's say these are elementary, or let me just say these are kids, age 2, 4, 4, 5, and 7. How many samples do I have? 5, right? Now, I want to produce several versions of that particular sample. This is the one version of it. Look at that. What happened here? Is there any new information? No, except that there's a duplication. 7, 7. Do you see that? This is just one version. That's what we mean. We can have 10,000. We can have so many versions of that same numbers. We're using sampling with replacement. Okay? So take a look at that. Now, what do we mean by confidence? You know, most of the time we talk about constructing confidence interval, right? I'm going to tell you what we mean by that. But before I tell you what we mean by that, I'm going to show you a conversation between Alice and Bob. I want you to pay attention to this conversation. Alice said, "Hi, Bob." And Bob replied, "Hi, Alice. Listen, you know that last phone that just came off the assembly line, is it actually working correctly? We should probably check." And Alice said, "I am 99.9% confident that it is working correctly." And that was the response of Alice. Alice was behaving like a statistician here. And Bob now said, "Wait, what? 99.9%? Why don't you just turn it on and check? Then you will know for sure." Of course, Bob is not behaving like a statistician. And you know, Bob actually believes in what he sees. But Alice said, "Do you even work here? This phone doesn't have a battery in it yet. Who do I look like? The evil emperor from Star Wars? I can't just shoot electricity out of my fingers and turn it on." Bob says, "So how are you 99.9% confident that it is working?" But you know what Alice said? Alice was using experience. In statistics, we use what I call the principle of subjectivism. Past antecedents. Ali now said, well, we make 10,000 phones a day here. And on average, only 10 of them fail quality control checks. Only 10 out of 10,000. And later in the process, after their batteries are installed, that is a 99.9% track record. And therefore, 99.9% confidence that this particular phone is working just fine. And Bob now said, okay, that makes sense now. Now, what am I trying to say here? When you hear confidence interval, if we say, oh, we are 95% confident that the true value of the parameter will lies, you know what that means? What do we mean by confidence interval in the first place? The confidence interval is the expected proportion of interval that will contain the value of the parameter, which means it is not all intervals that will contain the true value. If you're using 95% confidence, it means 95 out of 100, which means if 100 researchers should go into the same population, working on the same thing, we choose the same sample, and we construct 95% confidence interval for our study, it is only 95 of our intervals that will contain the true value. That's what it means. And for confidence interval to work, it relies, before you can use the conventional approach that we're using before, then the probability distribution of statistic must be normal. Confidence interval relies on the assumption that the probability distribution of the statistic must be normal. If it is not, that justifies bootstrapping. Now, how does the bootstrapping work now? I think I've already demonstrated that to you. We have several versions of that. This is the situation. We don't want to just base our inference on just one sample alone. We basically want to, have several versions of that. And on each sample that we generate from the original sample, we're going to call it bootstrap sample. From one original sample, we can produce several of those samples. We call that bootstrap sample. And on each bootstrap sample, we're going to have a bootstrap statistic, which may be X bar or P cap, depending on what you are working on. And in the end, we're going to look at the distribution of the bootstrap statistic because we expect them to vary. But if the distribution is normal, then we are fine. Any question? Okay. Now, this is the step to curate a bootstrap distribution. Don't forget we're using sampling with replacement from the original sample. Of course, we're using the same sample size. Okay. And we want to curate so many times. We want to produce more than 5,000 versions of that. Then we compute the statistic. We look at the bootstrap distribution, and we can actually conduct a confidence interval now. But the confidence interval we want to do now will be called a bootstrap confidence interval. That is different from the one that we did before in a quick review. How does it work? I'm actually going to demonstrate to you now with data. Let's come into this data now. I need you to pay attention. Statistics is very, very easy. Now let's get started. A sample of 20. Oh, sample of 20. Oh, sample of 20 is less than 30. You know that, right? Central limit theorem does not apply. It's not going to follow normal. Therefore, we need what? We need to bootstrap. Okay. 20 skateboard prices for sale online is recorded as skateboard prices. And look at the question. What does it mean? And standard deviation of the 20. Oh, that is the normal way of getting the mean from a simple. Then the second one, describe how to use data to select one bootstrap sample, describe how to simulate this process 5,000 times to curate the bootstrap distribution. Because if you want to curate a bootstrap distribution, you need more than one bootstrap sample. You need so many of that. Then construct and interpret 95%. Let's get started. This is my data now. You can try this. If you want to have access to this data, you need to load a package called log5 data. Now, what is the original sample size? 20. Do you see that? Original sample size 20. Do you see that? Now, the first question is asking you to find the mean and the standard deviation. And now, you're just going to write mean of that, standard deviation of that. That's all. The second question is asking you to create one bootstrap. One bootstrap. Number two, you can see that is a code. One bootstrap. Now, the next one is telling you, and when you create one bootstrap, when you find the mean for just one bootstrap, what do you get? 59.5835 for one bootstrap. But when you look at the original sample, the mean was 50.01802. They are not the same. Now, you now know the next thing you want to do now. You now want to produce several versions of the sample, because one bootstrap is not enough. Okay, now this is 5,000. Now this is the code. Now it means we're basically going to have 5,000 means. 5,000 means because we've produced 5,000 version of that. Then we draw the histogram. Oh, this is normal. When it is normal, then we can look at the mean and the standard deviation. We can look at the confidence interval. But I want you to pay attention to this now. I want you to pay attention to this now. This is the confidence interval that we have at the end of the day. Now, we can only justify our bootstrapping if that's sample mean, if the mean of the original data is contained in there. What was the mean of the original data? The mean of the original data was 50.01, and that actually lies in this interval. We are fine. That is the end of my lecture today. Any question? Okay, go ahead. Oh, you are asking whether can we have a situation where we're going to have without replacement, right? With replacement is better than without when we are bootstrapping. Although we also have some situation where we use without replacement. But with replacement, you're basically going to have a lot of information. That's a good question. Okay. The last lecture has been published, recording. Okay, you can check. I just published that this morning, and this is also going to be published. Okay, make sure you stay safe and have a very beautiful day. Bye for now, everyone.